Okay, in this section we're looking at substitution reactions involving alcohols. I would say about half of these are review from Orgo 1, and then we'll also learn a couple new reactions. Alright, so if you remember from Orgo 1, OH is generally a bad leaving group. So just reacting an alcohol with something like sodium iodide or sodium chloride is not going to result in a substitution reaction. And so one way that we learn to get around this in Orgo 1 is to convert OH into a good leaving group. And a good leaving group that we learned is turning it into a tosylate. And so if we react our alcohol with TSCl and pyridine, that will convert it into a good leaving group. It won't change the configuration. If the carbon that the alcohol is on is chiral, converting it into the tosylate won't change the configuration. And then we can do an SN2 reaction on the tosylate, right? And of course, an SN2 reaction then does change the configuration. And so, right, to kind of sum up, right, if I have an alcohol and I want to do an SN2 reaction, first convert it into a good leaving group, then I can do the substitution reaction as usual. Right? So we did do very quickly in Chapter 7, we talked about substitution reactions with other substituents, and one of those was alcohols. And so one of the things that we talked about is if I react a tertiary alcohol with an HX, right, where X is a halogen, under these acidic conditions, I can first protonate the alcohol, right, converting it into water, which is a good leaving group. Right, and then this will, because it's tertiary, this will proceed by an SN1 mechanism. So we'll lose the water as a leaving group. It'll convert into a carbocation, and then I'll get the nucleophilic attack of the bromide ion. In this case, right, we could do this with chloride or iodide as well. Right, we also saw that we could get substitution reactions for primary and secondary alcohols using HBr, but in particular for primary alcohols, this probably occurs via an SN2 reaction because a primary carbocation is not going to be very stable, right? But the first step of the mechanism is basically the same, right? We protonate the alcohol to convert it into water, which is a good leaving group, and then we get a concerted SN2 mechanism to get the substitution reaction. Right, it turns out for primary alkyl halides, this reaction doesn't work very well with HCl, so it works fine with HBr. For HCl, it requires using zinc chloride as a catalyst. However, due to the ionic nature of zinc chloride, this limits use of this reaction to cases where the alcohol is water soluble. So it only works with small numbers of carbon atoms, and so that limits its usefulness somewhat. Okay, so in terms of some new reactions, if I have primary and secondary alcohols, I can convert those into alkyl halides using two new reactions. So if I react it with SOCl2 in the presence of pyridine, I can substitute the OH with a chloride ion. And if I react it with phosphorus tribromide, I can substitute the alcohol for a bromide ion. So I want to at least look at the mechanisms, but you're not going to be responsible for reproducing these. But they both essentially involve converting the OH from a bad leaving group into a good leaving group, and then we can undergo an SN2 reaction. So first we get a nucleophilic attack, where the lone pair on the OH attacks the sulfur of the SOCl2. Right. We then have the loss of a leaving group where the chlorine pops off and we rearrange the electrons a little bit. The pyridine then acts as a base to have this proton transfer reaction. And so now we have a good leaving group. And so we can have both an SN2 reaction along with the loss of really two leaving groups. Okay, again, the reaction with PBr3 is sort of a similar idea. We convert the OH from a bad leaving group into a good leaving group. So we start with a nucleophilic attack and the loss of a leaving group. And then we can have the SN2 reaction where the bromine comes in and replaces whatever this thing is called. Okay, so I'm not going to make you responsible for knowing those two previous mechanisms, but we do want to be able to predict the products or choose which reagents we would use to accomplish the following transformations. So we'll finish off this video with a couple examples. Okay, so in this case, I have a secondary substrate, and I'm getting inversion of configuration. So both of those things are going to lead me to probably want to use an SN2 reaction. Of course, OH is a bad leaving group, so I think there are a couple ways that we've seen that we can do this. So one way would be to use first the TSCl in pyridine to convert the OH into a good leaving group, and then the second step would be to react it with something like NABR that's a good nucleophile, and that'll give me an SN2 reaction. A second scheme we could use is we could react this with PBr3 is the reaction that we just learned, right? And in that mechanism, we'll first add the PBr3, converting this into a good leaving group, and then we'll get a following substitution SN2 reaction. In this case, I think I prefer not to use HBr because I have a secondary substrate. I'm afraid that I may get a mixture of both SN2 and SN1 reactions, and because I want just the inversion of configuration, right, if I get an SN1 reaction, I'll get both enantiomers, which I don't want, and so I think these two methods are going to be a better choice. Okay, in this example, I'm starting with a tertiary substrate, and then these aren't enantiomers, they're diastereomers, because I have these two chiral centers, but at the chiral center where I'm getting the substitution, I'm getting both configurations, right? And so both a tertiary substrate and then getting both configurations is consistent with an SN1 reaction. So I think in this case, I probably would go with HBr, because that's going to give me an SN1 reaction, and the tertiary substrate is going to favor that SN1 reaction. Okay, in this case, again, I'm starting with a secondary substrate, and I'm getting inversion of configuration. So I'm looking at doing this with an SN2 process. And so I think, again, there are two ways that I would recommend doing this. So the first way, we can convert it into a tosylate by reacting with TSCl and pyridine. Then we could get an SN2 reaction using NaCl, or the new way that we learned in this video is I could react it with SOCl2 in pyridine, and we could also get an SN2 reaction with a secondary substrate.